Okay, let's start today's session. Okay, so good evening, everyone. So, welcome to the problem solving session for this thermal physics course, whose course ID is page 17, and the instructor of the course is Professor Debamalya Banerjee of IIT Kanpur. So, this is the problem solving session for week number 8, and I am Dibyendu. I hope that you guys are following the lectures of Professor Banerjee and you are getting some ideas. So again, it may sound repetitive. So in these sessions, we are just going to do some problems. But if you guys follow the main aim of these sessions are you guys have to follow the lectures, and then you have to uh, try to do some problems, and that's why I come into the picture. I will help you guys to solve those problems. I will discuss some problems. So that's the main theme. Okay, so let's start. So the first problem, it says, what is the temperature drop over 1 kilometer of atmosphere? So here it is, probably as we go upwards and onwards, uh, the temperature reduces as the height increases, right? So here we have to determine what is the temperature drop for if you travel 1 kilometer of height. Then some coefficients are given, that adiabatic, that expansion coefficient gamma for air molecules, because in our surroundings only presence of the surroundings is called air, right? It consists of different gas molecules, but as a whole this coefficient is given to be 1.4, and gravitational acceleration is 9.81 meter per second square, and universal gas constant is 8.31 joule per mole Kelvin, and the molar mass is given there for air. Okay, now so first, to solve this problem, we need to know. So you probably noticed that solving each and every problems, the main idea of doing those things is to first know how are we going to solve those problems, the steps, or you know the protocols to solve those problems. If we know how to solve those problems, then the algebra or the calculations will be much more easier. Okay, now since we have to find the temperature drop, if we get the temperature drop rate, temperature drop or change gradient, then if we know what is the temperature change per meter, then we will multiply that quantity with 1 kilometer, and we will get the overall temperature drop. So what does it mean? This temperature drop change or temperature gradient is how much the temperature changes per meter. Okay, that we have to calculate. let me uh, add someone. Okay, so that's the thing. Now in this system, the way it changes the gas, it actually, this changes adiabatic changes. Okay, this is adiabatic change. Follow, please see, I am writing, the basic concepts though that are associated with this problem. If we know these things, then we will use all of these all of these ingredients to solve the problem. This is adiabatic change or adiabatic process. So we have to first get the adiabatic lapse rate, and this adiabatic lapse rate, this actually, the relation for this is, so this is dt by th. T is temperature, h is the height. That means temperature change or gradient. This is minus gamma minus 1 divided by gamma and mg by r. Now for our system, gamma is 1.4, this is minus 1, this is 1.4, m is 0.029, 9.81 divided by r, 8.3. This will be Kelvin per meter, right? Now please solve it. Here the minus sign, it denotes that as temperature, as height increases, temperature decreases. That the meaning of this symbol is only that. Okay, so solve this problem and solve this calculations and tell me the value. Is it understood, this thing? So if you don't do this, I will do it for you. So this is 9.78 times 10 to the power minus 3 Kelvin per meter. Now this is the temperature drop. So one more point is negative sign indicates okay. Now so we have to, what is the height change? 1 kilometer. What is 1 kilometer? Is 10 to the power 3 meter. So now we have to, this is the capital H. So temperature drop will be 10 to the power 3 this height plus this rate. So let me write the equation, h times dt dh. So if you multiply that, that comes to be 9.78 Kelvin. So This is the correct option, 9.78. Okay, so is it clear? So what we will first, so to solve it, the temperature drop, first thing, as height increases the temperature decreases. Now again we get to know about the process. This is because of the adiabatic process. So we have to find the adiabatic lapse rate. What is adiabatic lapse rate? Is how much temperature changes per meter. We have found that coefficient, and then we have to multiply that rate with the height uh, of this specific problem, and we have got this 9.78 Kelvin. And what does this negative sign indicate? The negative sign indicates that as height increases, temperature decreases. Okay, so that is the main thing. So it's a quite simple problem, but this kind of problem will come in the exam. Okay, now here a column of air is suddenly expanded from initial pressure volume, which is P1 V1, to a final pressure volume, which is P2 4 V1. Now we have to find the pressure of the final pressure, which is P2, in terms of P1, and the adiabatic coefficient gamma is equal to 1.5 is given. Now can you do it? So what is the equation of state for adiabatic process? Anyone? We have discussed in the last class. Anyone? Unmute yourself. What is the equation of state for adiabatic process? Anyone? What is the equation of state for adiabatic process? Okay. So as we have learned in the previous class, this, so for adiabatic process, is PV for gamma is constant. Okay. So what is the initial pressure? Initial pressure and volume. Initial state is P1 and V1. That means pressure is P1 and volume V1, right? What is the final state? P2 and V2, but V2 is 4 V1. So that is that. Okay. Now we will use this equation of state. This equation of state, PV gamma equal to constant. So first thing is P1 V1 to the power gamma is constant. That will be equals to P2 4 V1 gamma, right? Now if you just calculate P2 by P1, that comes to be V1 by 4 V1 to the power gamma. And what is the value of gamma? Gamma is equals to 1.5. Now that gives you P2 by P1 will be 1 by 4 times 1.5. And what is 1 by 4? 1 by 4 is 2 to the power minus 2. What is 1.5? Is 3 by 2. 2 cancels out. It will be 2 to the power minus 3. What is 2 to the power minus 3? This is 1 by 8. So that becomes to be P2 will be P1 by 8. Is it okay? So the final pressure will be 1/8 of initial pressure. Okay. So that's the thing, right? So here this is adiabatic expansion. So it expanded from initial state to a final state. In the final state, the volume gets quadrupled, means 4 times increased. So if the adiabatic coefficient, expansion coefficient is 1.5, then that final pressure will be 1/8 of the initial pressure. Okay, so that's pretty simple. So let's go to the next problem. So this problem says, let me read it out. A refrigerator is working between temperature of melting ice. What is the temperature of melting ice? What is the temperature at which ice starts to melt? Anyone? What is that?
100 degrees Celsius, sir.
What? I didn't get to hear you. Jivan? Jaga Jivan? You are saying something. Please unmute yourself. What is the temperature when ice starts to melt? Jaga Jivan? Anyone? Manirasi, Kirtiga, Nana Shekhar, Denmori, Renuka Devi.
0 degree Celsius,
Yes.
32 degree Fahrenheit, sir.
Yeah, exactly. Precisely. So as Jagajivan rightly said, that melting ice is 0 degree centigrade. So we got to know the temperature, first one temperature, and the second temperature is that of outside atmospheric temperature of 17 degrees centigrade. So that is expected, right? For refrigerator, the internal temperature is less compared to the outside temperature. That is the purpose of refrigeration, right? Now They said to calculate the energy required to freeze 1 kg of water at 0 degree centigrade. Now, what is the how? Let me first ask you, when some goes water at 0 degree centigrade freezes, then what so the amount of heat it rejects or it emits, what is that heat called? Certain type of heat, that is not a convective heat or conductive heat. There is a certain kind of heat. What is that heat called? When water at 0 degree centigrade becomes or starts to freeze, then the amount of heat it emits or amount of heat it loss, that heat is called a certain type of heat, right? What is that heat called? Have you heard about latent heat? That is also given in the question. So you guys, if you guys are careful enough, then you should have answered that it is a latent heat. So by uh, gaining or losing latent heat, this water by gaining it, actually water becomes steam, or ice becomes water. By losing, steam becomes water or liquid, and water becomes ice, solid. Okay, so that is the thing is it's done. Okay, now if, let me write, the latent heat is given, right? Then uh, latent, now this energy required to freeze 1 kg of water at a degree means this energy of this refrigerator, how much work or energy the refrigerator should take. Now latent heat lost for water to ice making is, so how much water? 1 kg. So 334 times 10 to the power 3, because 1 gram is equal to 10 to the power 3 this joule. Okay, now this much amount of heat is required. Now for a refrigerator, so this is the amount of heat, this is the work done, this is W, this is Q, right? So this is TC, TH. This is the diagram for a refrigerator. Now we have to for forming of ice, we have to reject this amount. We have, by doing some mechanical work, we have to first eject this amount of heat. Now, why energy required for this this heat transfer, or this heat it transfer from this to this? Why is it required? Can anyone volunteer to answer that? Heat flows from certain direction, right? Heat flows from which direction? Anyone? heat flows a certain direction, right? Spontaneous actually. Now, not the spontaneous heat flow follow a certain direction. Can anyone tell me? Spontaneous means you don't have to do any work. It just flows by its own. In which direction heat flows naturally? In which direction? If you touch a uh, red hot metal surface, what do you feel? Anyone? Jagajivan? What do you feel when you touch one red hot metal surface? If you dare to touch, you will feel certain sense of hot, right? Or burned, because heat flows naturally or spontaneously from a hotter temperature to cooler temperature, right? So, but in the case of refrigerator, here, if you follow the heat flow diagram, you are flowing heat, from hotter temperature, from colder temperature to hot temperature. Then how will it be possible, right? That's why we have to, you cannot do this spontaneously. Refrigerator cannot spontaneously emit heat or reject heat from the substances it capture, substances it hold. That's why we need electricity, we need some electrical work to and mechanical work to pump out the energy from that thing, from inside the refrigerator, right? So that's a crux. Here is the concept. The concept is that for refrigerator, that's why required, there is some work required. Otherwise, it should spontaneously flow the heat. So again, so my question was, why energy should be required? So let me write it clearly, otherwise you guys will forget. Heat flows spontaneously from higher temperature to lower temperature. Now, to eject heat from Tc to Th, we need some external work or energy, right? That's why it is important. Now for refrigerator, there is a relation, right? So this is the Q, this is the amount of heat we need to be displaced, this is the Q. So this is the amount of heat we need to eject from refrigerator, okay, so that water becomes or freezes to ice, right? Now this relation is like this. This is Th by Tc minus 1, right? How because refrigerator, how are you going to get it? Refrigerator is reverse of heat engine. Now this is Q prime for heat engine. Q prime by Q is Th by Tc. Now if you do Q prime minus Q, then it becomes Th minus Tc by Tc, right? And this is Q prime minus Q is W. So W by Q is Th by Tc minus 1. Now Th, hot temperature, the outer temperature is 17 degree centigrade. That means 273 plus 17 Kelvin. That means 290 Kelvin. And Tc is 0 degree centigrade. That means 273 Kelvin. Now do this calculation and tell me what is the energy required. Okay, please tell me what is the energy required. Do the calculations, because we have given the formula, we have given the value of each and every variable, and we have to find the W. Renuka said 20.8. Anyone else? Okay, looks like nobody has solved it except Renuka. So let me check with my calculations. It seems it's okay. So Q is 334 into 10 to the power 3 joule. So W by Q is Tc, Th by Tc minus 1. That becomes 290 by 73 minus 1. So 17 by 273. So W is 334 times 17 by 273 into 10 to the power 3 joule, and that coming out to be 20.8 kilo. So Renuka, you are absolutely right. This is 20.8 kilo. Okay, so here lots of concepts are involved. So I hope that you guys have understood the each and every points, because it seems that the calculations is very easy, but if you do not own the concept, if you do not grasp the concept, then you cannot solve the problems, because in other problems they will just play with the languages and you will not get to solve it. Okay, so let me proceed to the next problem. So this problem says a Carnot engine is operating between 10 degrees centigrade and 859 degrees centigrade. Find the efficiency. So you guys have probably followed the lectures, but I will just briefly tell you about this. So a Carnot engine is a reversible ideal heat engine, and people researcher, and it has been proved that Carnot engine is the engine whose efficiency is the highest for any kind of heat engine. Ideally, no other heat engine can surpass this Carnot engine. But in recent times, there are different kind of active heat engine, which in that field I do my research. There are different reports that active heat engine could surpass this Carnot engine's efficiency, but that is a discussion for another day. So Carnot engine is a reversible ideal heat engine. So what is a heat engine? Heat engine is pretty simple. So there are two baths, hot bath and cold bath. You take some heat and you do some useful work, and resting you just ejects, right? So TH, this is TC, and Q1 is W plus Q2. Since these are, and it follows a different cycle, so there are, let me draw, this is P, this is P, let me write, let's say 1 2 3 4. This is isothermal expansion, this is adiabatic expansion, this is isothermal compression, this is adiabatic compression. Okay, now here the efficiency, this is called efficiency. So efficiency is always taken by what amount of work you get from the heat engine, what amount of work you get from the heat engine by Q1, right? So this will be W by Q1. What is W? W is Q1 minus Q2 by Q1. And due to this, from this cycle you get to know this Q1 by Q2 is T1 by T2. So Q1 minus, so here it will be TH by TC. So Q1 minus Q1, Q1 minus Q2 by Q1 will be TH minus TC divided by TC, right? Right? Okay. So probably okay, there is some problem. So this will be TC TH minus TC divided by TH. Okay. So that becomes to be 1 minus TC by TH. So efficiency eta is 1 minus TC by TH. And what is TC? TC is 10 degrees centigrade and TH, how much is TH? 859 degrees centigrade. So this will be 283 Kelvin. Yes, of course, when is this all this time temperature will be in Kelvin. This is 273 plus 859. So this is 2, 1, 3. Okay. So please do the rest of the thing and tell me what is the answer. What is D, Renuka? 0.748. So you are saying 0.75. Okay, we will see. Other so other people. Okay, looks like Renuka has done it correctly. So this is 1 minus 283 divided by 1132 so this looks like uh, oh, this is 1 by 4, so this is 1 by 4, so 1 minus 1 by 4, so this is 0.75. So option D is the correct one. Okay. Okay, thank you, Renuka. So next question. A reversible process must not be accompanied by option A friction, option B viscosity, option C hysteresis, option D all of the above. So what is reversible system? First, anyone who wants to answer? Anyone? If you follow the previous class, in previous class there was probably one discussion about the reversible process. There I told you about some friction, dissipation. So from that you have probably guessed one answer, which is friction. But viscosity, what is viscosity? Viscosity is a friction to the flow of the fluid. So that is one kind of friction, right? And what is hysteresis? Hysteresis is there are different kind of memory involved, right? Hysteresis means that it actually remembers the path. It has some memory inbuilt, right? Okay, so let me write some definitions. So reversible process is such a process where the forward and backward processes both are equally likely. What is equally likely means? Equally probable. Okay. Now, if there is dissipation in the system, then so equally probably means no arrow of time, no arrow of time. So if there is dissipation in the system, then there is arrow of time, and if there is arrow of time, then there should be memory, because it determines, right? So for friction, let's say you starts from here A to B and it's from B. If there are friction in this path, you get to know that from A to B you will lose some energy. But if you think of a, a process B to A, you will get some unnoticed energy input in the system which are unphysical. So this is not possible for reversible. For viscosity, same thing. So this is also not possible. From hysteresis, you probably get some curve like this. It starts from here, so it doesn't follow the same path. So it grows from here and reaches here. So it doesn't follow the same path, it follows a different path. So this is also not possible. So here the correct option should be all of the above. So for a reversible process, so there are different fold of thinking. First, a reversible process where when you start from certain state and you goes to a certain final state, if the process is reversible, then there will be equal probable chance you start from final state, you get to initial state. Okay, Now if this process where the final and initial state doesn't matter, that is called reversible process, because there is no arrow of time, there is no sense of arrow, there is no sense of time proceedings. So there is no certain mark of time. But if there is dissipation in the name of friction, so let's say you are some you are going from A to B. When you are moving to forward, you are dissipating some energy. But if you play the movie backwards, then there will be some unphysical event happening. Some energy which has been lost will be gained in that process, which is unphysical, right? That's why that could be totally, you know, that could be totally identified from a real thing. So that is not a real thing, right? When you are just reversing the film, you can see that people are moving backwards, but that is not real. So in that process, so these things are not reversible. Okay. Now this question says a Carnot cycle is operating between source of temperature T1 and sink T2, which is the most effective way of increasing the efficiency of the engine. Now, what is the efficiency of the engine formula? So, efficiency of the engine, that is eta, that is 1 minus Tc by Th. Tc is the temperature of the cold reservoir, Th is the temperature of the hot reservoir, right? Now, so this can be written as 1 minus T2 by T1. Now there are different the hot reservoir. So hot reservoir is called source because it emits some heat, and cold reservoir is sink. Okay, rejects heat. Now what is your guess? In which case the efficiency should be more? If you decrease the sink temperature, or if you increase? First thing first, if T1, which is, so first, if to get the efficiency higher, T2 by T1, this quantity, T2 by T1, this quantity, that should be decreased, right? If we decrease this ratio of T2 by T1, then the efficiency will be increased. Now there is T2 by T1, so how can it be increased? First, if we increase T2, or if we decrease T1, two possibilities, because T2 is numerator and T1 is denominator. So if we increase T2, eta will increase. If we decrease T1, eta will increase, right? So let me write there first. two possibilities. First, increase T2. Option B, decrease T1. Now, in between these two, which will be more effective? We'll see that, right? That's why I'm saying, what is your guess, or how are you going to solve it? Anyone? Renuka? I will wait for 1 or 2 minutes so that you guys can respond. No response. Okay. So what we have to get this expression, this expression is A by T2 by T1. Now let's differentiate with respect to T2. Okay. What is dA T2? That is 1 by T1. What is dA T1? Is T2 by T1 square. Now if you compare dA by T2 dt2 and dA by dt1, then this is 1 by T1, this is T2 by T1 square. So this will be T1 by T2, and T1 is always greater than T2. So if we change dA T2, that is, now here why are we using mod sign? Because the change of T2, the change of temperature for T1 or T2 are different. For T1 we are increasing, we are decreasing, and for T2 we are increasing. So here in this case, this is, that's why we take mod. So there will be, if we haven't put this mod sign, there will be minus. Minus sign means if we increase T1, this quantity A decreases. Okay. So that's the thing. So since we have get the gradient, the change of this quantity A with respect to T2 is greater, so we will write that decreasing T2 will yield more efficiency. Okay, I will come back to this problem, but is there any problem? Have you understood the problem? How we have solved it? So if that is T1 greater than T2, then this should be greater than 1, and that's why we have written it. Okay, clear? Clear? I hope it is clear. Anyway, let me proceed to the next problem. What this question says, a Carnot engine has 25% efficiency. What is the efficiency? 25%, 0.25. If the temperature of the sink is reduced by 100 degrees centigrade, its efficiency is doubled. Find the temperature of the source and sink respectively. I will write the equations and I will expect that you guys solved it. Let's write. Let's temperature of sink. This is T2 and source. This is T1. What is the efficiency eta? Eta efficiency is 1 minus T2 by T1. For first case, eta 1 is 0.25, when that is 1 minus T2 by T1, and the second case eta 2 is doubled, that means 0.5, that is 1 minus T2 plus 100 divided by T1. Please solve it and then tell me the T1 and T2. Please solve it and tell me the answer in the chat box or unmute. I will take 2 minutes or 3 minutes break. So in meanwhile you guys solve it. Okay, I have written the equations and solve for T1 and T2. Anybody solved it? I will again wait for 1 or 2 minutes because this is pretty simple. You guys are you should solve it because these are simple algebra, right? Renuka, no answer. Anyway, okay. So this is 0.25. So here it will be T2 by T1 will be 1 minus 0.25, that will be 0.75, and for this case this will be 0.5 is equal to T2 plus 100 by T1, and if you solve both this thing, then T2 by T2 plus 100 will be 0.75 by 0.5, which is 3 by 4 times 1 by 2, so 3 by 2, and after doing this will be 2T2 3T2 plus 300. So reduce, so this is minus. Also nobody pointed out that this will be minus. Don't know. So this will be minus, so T2 will be 300. Okay, now if T2 is 300, and from here we can get T1 is equal to 0.75, sorry, T2 by 0.75, 300 4 by 3, right? So this will be 400. Pretty simple problem. So for temperature source sensing, this 400 and 300. Okay. Okay. So next question. Next question says the criteria of a process to be reversible is that it must be option A non-static, that means dynamic, option B non-dissipative, option C quasi-static, option D both B and C. Now, okay, Renuka said option D. Okay, so why not non-static, Renuka? Renuka, why not non-static or dynamic? Okay, Renuka has some mic problem. Okay, so Renuka has rightly said that will be both B and C, because first criteria for reversible state, reversible process, it has to be infinitely slow. Now, if it is infinitely slow, this is quasi static. That means the process is not dynamic. Okay, so non-static option is wrong, right? Now there shouldn't be, there should not be any dissipation. That also correct, right? So non-dissipative. So option D, both B and C. Okay. Now here, a electric current of 10 ampere is maintained for uh, for 10 seconds in a resistor of 25 ohm, while the temperature is kept constant at 27 degrees centigrade. Calculate the change in entropy. Calculate the change in entropy. Anyone? Electric current of 10 ampere is maintained for 10 seconds in a resistor of 25 ohm, while the temperature is kept constant at 27 degrees centigrade. Calculate its entropy. What? I did. Which one explanation you want? This one or previous one? I haven't told. I haven't solved it yet. I just asked the question that what is the correct option. I just asked. I just opened the question to the forum. Electric current of 10 ampere is maintained for 10 seconds in a resistor of 25 ampere while the temperature is kept constant. Calculate the change in entropy. Now, how what is the formula for heat produced in electric wire? What is the formula? There, you said option B. Okay, let me tell you. Now, H is I square R T. I is 10 ampere. This is 25 ohm for 10 seconds. That is calorie, right? Sorry, joule. Which would be the unit? Ampere second. Let me get the unit. Electrical heating. Okay, so this is called Joule's equation, right? So this is will be Joule. Now, if that is the case, this is 25 into 10 to the power 3 Joule. Okay. Now temperature T is 27 degrees centigrade, that means 300 Kelvin, right? Now change in entropy delta S is delta Q by T. What is delta Q? This is the amount of heat changed, right? Now if that is the delta Q, so this will be 25 times 10 to the power cube by 300. So this is joule per Kelvin. So this will be 25 by 3 into 10 joule per Kelvin. So this is 8.33. But if that is the thing, this will be 83.3 joule per Kelvin. So in that case, no other option is coming out to be true. Okay. But there should be some error. Now if they say that whole system is kept isolated, then the entropy change for the whole system will be 0 because there is no heat exchange. But here some amount of heat is being exchanged at this temperature. So that should be just divided by delta Q by divided by T, and that should be this. Okay. Clear? Renuka? Let me see what C. Yes, ds is equal to dq by dt. Yes. Okay. Okay. So which of the following is an extensive property? What is extensive property? Anyone? Extensive property is something. Now, extensive property is someone written something independent of mass. Yes, you can say that, but rather it should be written as independent of extensive property is not independent of mass. Intensive property or extensive property, this is not depending on the mass. It depends on whether it changes with the system size. Mass itself is an extensive property, is an intensive property because it changes, right? So that to be careful. Okay. So extensive. So there is some list. So extensive property is like the value of certain physical quantity depends on the size of the system they are subjected to. And there comes also intensive, means if uh, a volume is doubled, means the system, there is like, if volume is doubled, mass is also doubled, because if the size of the system doubled, the mass volume both are doubled, right? So that depends on the system size. Now what is intensive? Does not depend on system size. Means if V becomes 2V, temperature does not change, does not change. So temperature is a intensive property. Now tell me here, is pressure extensive or intensive? Pressure extensive or intensive? Does pressure depend upon the, so how much pressure I exert on the gas, that is totally independent of the system size. So this is intensive. So intensive, so let me write it here. So pressure is intensive property. Entropy is extensive, because if system size increases, entropy increases. Internal energy, that is also extensive. So B, C both. So option D is correct. So that is the end of these problems. So I told you that I will discuss this thing again, this problems and this problem. So let me discuss here again, or review, take a review sort of a thing. So today we got to first we have talked about how temperature changes with increasing height. That's why since the air we are in, the expansion needs adiabatic expansion, there should be adiabatic lapse rate, that is called how temperature changes with increasing height. Now the negative sign in the expression, that does mean that as height increases, it decreases, temperature decreases. So we have calculated that thing. Then we calculated how pressure changes in a adiabatic process when volume is quadrupled, and we got to know that pressure becomes 1/8 of the initial pressure. Then we got some idea to get different the energy to required freeze. There we got to know about latent heat, how heat flows. Heat generally flows spontaneously from higher temperature to lower temperature, because that is the natural course of heat flowing, right? Because why is it so? Because if there is higher temperature, that means that is has more heat compared to the lower temperature, right? That's why heat flows from higher temperature to lower temperature. First of all, what is temperature? Temperature depicts that how much heat one quantity, one system possesses, right? That is the meaning of temperature, right? If there is more, if one object is of more temperature, that means its heat energy is more compared to the lowest energy, lower temperature. So that's why heat engine, it is easier to get some work done when you eject when heat engine ejects some heat from higher temperature, and it produces some useful work, and then some amount of heat will be transferred to the lower lower heat source or heat reservoir. But in the case of refrigerator, the system is different. You have to defy the natural timeline or natural course of flow of heat, because you have to eject some heat to the hotter temperature. That's why you need to have some other external source of work or energy. That is, we have done using different concepts. So first, how much heat we have to transfer, that is the latent heat required for the water to be freezed. That is, we have calculated that, and from refrigerator calculations we got that W by Q is equal to TH by TC minus 1, and after some lengthy calculations we got to know that that is the value, right? Then this is a natural Carnot engine problem. We know the efficiency formula, we have used the formula, and we get the temperature and the efficiency. Okay, this is simple problem. Then again, which process are to be called the reversible? We have talked about those things, and we have got to know that for a reversible process, the arrow of time, there is no arrow of time, but for an irreversible process there is an arrow of time. That's why in a reversible process, the different kind of friction, viscosity is a resistance to the flow, and hysteresis, different kind of things are not accompanied with a reversible process. Then we talked about how we can increase the Carnot efficiency. So we first talked about that efficiency will be higher if this ratio T2 by T1 is small. So that's why we got this expression T2 by T1, and we got differentiate with respect to T2 first, that is got to be 1 by T1, and dA T1, this T2 by T1 square, we have taken the mod, because if we increase T1, the this quantity will be different, right? The efficiency will be negative, because the change is it's reverse. So that's why we got to get that if we decrease the source sink temperature more, the efficiency will be higher. So then again we got this two different efficiency from different sink and source temperature, and we got the relation and got the value of T1 T2, and here again the criteria for the reversible process were discussed, and here again we calculated the change in entropy for electric wire which is been heated, because it produces some heat. And then again the extensive property and intensive property of different systems, because extensivity and intensivity does depend on the system size. Intensive property doesn't depend on the system size, no matter how big you system, how big you subject this system to be. But for extensive system, that changes, but for intensive system the value of this quantity doesn't change. So if that is the case, then this is the end. So again, thank you, and thank you Renuka, thank you Tenmodi, Jagajivan, everyone. Okay, so we'll meet again next Monday at this time. So till then, take care.
Thank you.
Yeah.